I have the microphone today, so the quality is not going to be as crystal clear as it normally is, but we're back again with another fun-filled, action-packed, non-flipped Algebra 2 classroom video. Last note section before the big test. Note number 6, graphing natural logarithm functions. Now, very quickly, let me just riddle you this, guys. You see the word natural, so what number do you think this is going to involve?
2.
Yeah, Euler's or Euler's number, right? The E, right? That's when you see the word natural, it's going to involve E. Because remember, E is the natural base or the natural growth constant. All right, so let's write this down. Here we go. So, the inverse, it's not frozen, is it? Okay. The inverse of the natural exponential function. Do you guys remember what the natural exponential function is? F of x equals what? E to the x, that's right. The natural exponential function. Natural tells you E, and exponential is, raised to the x. Alright, so the inverse of the natural exponential function would be... Can anybody guess this? Actually, most of the classes did guess what the inverse would be. What kind of function is inverse of exponential? Logarithmic. So the inverse would be f of x equals log, what do you think the base is? E of x. Exactly. Very good. Very good. F of x equals log base E of x. Alright, that's what the inverse would be. However, big but, we have a special notation for this, actually. Just like, the common log when you don't write the base. What is the base when you don't write the base? 10, right? That's special notation for a common log. You also have a special notation when the base is E. And it looks completely different. It is ln of x. So I'm going to write two equations here. Y equals ln of x. So ln of x is the same thing as log base E of x, okay? So when you have a base of E as your log, that's the same thing as ln of x. ln stands for natural log. Bless you. Alright, I'm going to do a little graphic here to just illustrate, but natural log? ln? Yeah. Alright, I'm making a little graphic here, but e to the x. So y equals ln of x and y equals e to the x, they are inverses. Alright, inverses. Because ln of x is the same thing as log base e of x. Alright? So the first thing that we are going to do today is graph this parent function, f of x equals ln of x. This is the parent function. And I'll make a note here, it is the inverse of e to the x. The inverse of e to the x. So, if you know that ln of x is the inverse of e to the x, how would we graph ln of x? What do you think you would do to find some points? That's right. We can find the table, the points for e to the x, and then take the inverse, because ln of x is the inverse of e to the x. So let's see if we remember here. X and y equals e to the x. If I had negative 1, 0, and 1, what were my y values for e to the x? Wait. Let's start with a 0. At 0, what's it going to be? 1. What's it going to be at 1? 2.72. Very good. And what's at negative 1? Very good. Yes. So that is y equals e to the x. Now, we're not graphing that. We're graphing ln of x, which is the inverse So what are we doing for the inverse? Right, and then what are my y's? Very good. Yes, so these are the basic points for the parent function, y equals ln of x. Alright, so let's graph that. We got 0.37, negative 1 is about right here. 1, 0, and 2.72, 1. So the graph looks, let me zoom it in a little bit. Need 2 fingers to zoom this one in. All right, here we go. Boom. Boom. Notice our asymptote this time is not left and right, it is up and down. So, what is the equation of my asymptote on this parent function? X equals 0. Very good. That's how it always is for parent functions of logarithmic. X equals 0. If the asymptote is x equals 0, what's the domain? That's right. Where did you get the 0 from? The asymptote. And how did you know it's greater than and not less than? It's on the right side. Yeah, remember, the right side of a graph is more positive than the left side, right? So that is greater than. And then lastly, what is the range? Right, negative infinity to positive infinity. Now also, negative infinity to positive infinity is the same thing as saying all real numbers, right? So you can also just write the all real number symbol if you want to. A little quicker. But it's the same thing. Alright, so that is the parent function of f of x equals ln of x. So now we're going to do 2 transformation examples. So, here we go. First one's going to be, let me zoom it out a little bit. First one's going to be f of x equals 2 times ln of x minus 3 in parentheses. Now, what is the first thing that you want to write down when you have a function with transformations in it? You want to write down the transformations. Very good. Ooh, every class has said that today. So what are your 2 transformations here? Vertical stretched by 2, and then? Right 3. Very good. Alright, let's get these points for ln of x. Let's see if you guys have memorized it then. What are my points for ln of x? 0.37, 1 and 2.72, very good. And then what are the y's? Right, so if you already memorized e to the x, you know it's very easy to get ln of x because it's just flipped over. So there it is. Okay, so I'm going to show you the graphical way because that's the way I like to do it. But we're going to graph the original, so 0.37, negative 1, 1, 0, and 2.721. Alright, here we go. I'm going to zoom this in so you can really see the points here. Alright, so these are my parent function points. I'm not trying to graph the parent function though, I'm trying to graph with the transformations. So I got 2 transformations that I need to take care of. First one is vertical stretched by 2. And remember what that means is, how far away is each point from the x-axis? I'm going to double that distance. So take a look at this very first point right here, right? How far away is this point from the x-axis? 1. So instead of 1, how far away should it be? 2. We're doubling it, all right? Don't think about shift. It's not a shift. This is stretch, right? So you're literally doubling the distance. So it's going to end up right there. Now you see this next point that's on the x-axis? How far away is that from the x-axis if it's on it? 0, right? If you double 0, what is that? 0. So should that move anywhere? No, that stays where it is. Because doubling the distance of 0 is still 0. But then our last point over here on the right side, how far away is this from the x-axis? 1. And if I double that, what should it be? 2, right? So it should be 2 away from the x-axis. It'd end up right there. All right, so remember, it's not shifting, you're doubling, all right? It's a stretch. And so when you connect your points, your graph should look something like this. Oh! Wow, the second time I've done it today. I was just testing you, huh? Okay, anyways. Yeah, right 3. So you take each point, you move it to the right 3. So this point right here, 1, 2, 3 right there. This one, 1, 2, 3 right here. This one, 1, 2, 3 right here. Alright guys, after you shift it right, the shape should be the exact same, right? Before and after the shift. So if you shift it and then your shape change, you know, pay attention to what you're graphing, you know, and realize that you must have made a mistake if the shape is changed. There's the graph right there. asymptote is going to be right here. So can you tell me what the equation of the asymptote was going to be? X equals 3, right? You're right, the value is 3, but x equals 3. That's the up and down line, the vertical line, all right? If the asymptote is x equals 3, then what is the domain? X greater than 3. Once again, just to clarify, where did that 3 come from in the domain? Asymptote, how did you know it's greater than? Because your graph is on the right side of the asymptote, right? And then the range, which is always the same, right, negative infinity to positive infinity, or also you could write all real numbers. Boom. And now we're going to do one last transformation example. This last function is going to be, please do not lag. Last function is going to be f of x equals ln of negative x plus 2. Alright, yeah, so let's write the transformations down. In order, okay, because it matters what order you do them in. That is correct, Trey. So the first one is reflect over y. The negative sign on the inside is reflect over y. Where would the negative sign have to be if it's reflect over x? In front of the ln. That's right, at the very beginning. Right? At the very beginning. Okay, so, or as you like to say, after the equal sign. But anyways, reflect over y, and then what is the last transformation here? Plus 2, right. Okay, yeah, you're tricking me here. Up 2. That's right, it's up 2. Yeah. So these are the two transformations. This will be very easy to graph without using the table here. So let's get our first points though, just for the basic. What are the basic points here? Right, and what are the y values? Right, so let's graph our parent function points and then we'll do the transformations. 0.37, negative 1, 1, 0, and 2.72, positive 1. So here are my basic parent function points. Always start there, and then we just transform these points. And this will be very simple to do without a table, because the first one that we have is reflect over y, right? But what does that mean? If you were to describe it to somebody, what would you tell them? What does it look like? A mirror image over the y-axis, exactly. That's very easy to describe, because I can picture that. Look, mirror. Look at this perfect mirror image. Wow. If I folded this paper, you know, the points would land on each other. That's a mirror image. And then we got one more transformation, which is to do what? Up 2. So I take all these points and I move them up 2 units. So like this. 1, 2. Boom, right here. This one over here. 1, 2, right there. This point down here. Go up 1, up 2. Ends up right there. So then you can see our graph is going to look like this. Whew. And so the asymptote is right here. That's right, x equals 0. Hang on a second. Alright, so the asymptote here, asymptote is x equals 0. The domain, x is less than 0. Why is it less than this time? Because your graph, right, is on the left side of the asymptote. Very good. And the range? Right. And that's the transformations, you see? So this is the same as an exponential graph. It's the same idea, except now our base is e, which is 2.72, log base e, which is natural log. So let's go to the back side. Now this is where you're going to need your calculators. So the trusty, dusty calculators. All right, here we go. All right, we did this yesterday, but now we're doing it with a different function. Use your calculators to analyze the minimum and maximum values of the function on the given interval. Now, look at the first example. F of x equals ln of x, the natural log of x, okay? Would it be correct for me to tell you that the minimum is 5 and the maximum is 7? Why not? Yeah, those are the x values. We've got to plug them in to get the y values, which is what minimum maximum is asking for. So, can you tell me what my equation to find the minimum would be? ln of 5, right. So put that in the calculator and let's see what you get. Let's make sure we all get the same answer. Let's round to 2 decimal spots. That's right, 1.61. So that's what you should have gotten if you put in ln of 5 into the calculator. Notice on your calculator, ln is control e to the x, right? They're letting you know even on the calculator that ln is the inverse of e to the x. Okay, so how would I find my maximum then? What's my equation for the maximum be? Which is? That's right, 1.95 about. That's what you should be getting. Very good. So you got to plug those numbers in to find the minimum and the maximum. Yeah, control e to the x. Because you'll see that on the e to the x it says ln. And then you put the number. The second example, our function has changed. It's ln of x plus 2, okay? Be careful for the plus 2. And this one you actually don't even need a calculator. What would my equation be to find the minimum? Minimum equals, what's the equation though? And see that? Yeah, so we got to be careful. The plus 2, don't forget about the plus 2. ln of 1 equals what?
Zero.
ln of 1 is 0. Did you put that in the calculator or did you know that? Yeah. Did you put that in the calculator or did you know that it equals 0? Oh, okay. Yeah, well, remember on the front side of the paper, right, when we were doing the table, when we had the x and the y value, remember when we plugged in x is 1, what do we get for the y value? It was 0. If you look at your chart, right, it's 1, 0. So that's how you know ln of 1 is 0. And if we add 2 to that, what's my final answer here? 2. Right, so the minimum is 2. Let's take a look. Oh, well, I switched the colors, dang it. Okay, well, oh well. Let's look at the second one, maximum. What's my equation to find the maximum? Right. This one also, you don't need a calculator because, does anybody know what ln of e squared would come out to be? No? It's 2. How did you know that? Alright, you're a cheater. Okay, so remember, ln is the same thing as log base e, right? Remember that? ln is the same as log base e. So if it's log base e, and then the base of my number is e, what happens to that? If you have the same log base and base of a number, what happens with those? They cancel out, right? That's the inverse property for logs. So this cancels out, which leaves you with 2. Plus 2 equals, and that is your maximum. And let's take a look at the very last question over here. F of x equals log base e of x minus 3. So you see the question right there, it looks a little different, but we have to recognize, this is where they want you to see if you understand. Log base e of x is the same as what? ln of x, that's right. So this is actually f of x equals ln of x minus 3. So then how would I find my minimum? Right? Minus 3, which is about what? Let's put that in the calculator. ln of 3 minus 3. Negative 1.90, very good. What would be my equation to find the maximum? E cubed, right? Minus 3. What is ln of e cubed? 3. Remember, ln cancels out with the base of e. So that leaves you with just a 3 minus 3, and which equals, right, so you're giving me the whole answer? I thought you were telling me the answer for ln of e. Yeah, so yeah, you're right then. Yeah, notice that all these numbers make sense because the maximum should be a bigger number than the minimum, right? That's how all of them are. So make sure you just in case, sometimes, the functions change a little bit. The minimum maximum will switch spots. So make sure, though, bigger number, that's maximum. Smaller number, that's minimum. All right, so that's very good. And now we've got to make a note before we start the next examples. And it is going to be, remember. ln of x is the same as, what is it the same as? Log base of e to the x. Or log base of e of x. Log base e of x. Remember, e to the x is the inverse of ln of x, okay? Okay, so because ln of x is the same as log base e of x, so all log properties also apply to ln. Let's try. Yeah, okay. Yeah, because ln is a log, it's just with the base of e. All the log properties are also going to apply to ln. Remember, these are the product property, the quotient property, inverse property, power property, and change of base. So, here we go. So you've seen this before, but also there's going to be a little clarification that I give you later, because some people might have been a little confused on some of these. So, first example, we're going to simplify with log properties expressed as a single log. So A is ln of x plus ln of y. How can I make that into a single log? X times y, right? This is the product property. Very good, that one is simple, one step. B is a multi-step problem. What would you do first on B? What would you do first on B? Outside what parentheses?
Well, like inside.
No.
What are you saying, Jaime? ln of what? Okay, so Trey said it while you guys are bickering over there. It's 3 squared. Remember, this is the power. This is the power property, right? The 2 in the front, it can be moved into the exponent, and vice versa. The exponent can be moved to the front, right? So we're trying to make it into 1, so we're going to move it back into the exponent. All right, so plus ln of 7. And now I want to simplify. Okay. I want to simplify a little bit. What is 3 squared?
9.
So this is ln of 9 plus ln of 7. Oh my gosh. All right. Right, equals ln of 9 times 7, which is ln of... What's 9 times 7? 63. So this is ln of 63. You got to simplify, which means go as far as possible, right? There it is. ln... no, not this part. Because this part you don't have to write the actual number. You just get there and you're done. All right, C. We got ln of C minus ln of D. How can I write that as a single? So what would it be?
ln of C divided by D.
Right, ln of C over D. Very good. That's it. Easy. Next, D. Again, a multi-step problem. What do you do first here?
ln 4 cubed.
Right? We want to step at a time. Right? What is 4 cubed is what?
64.
64. So ln of 64 minus ln of 2. Then what happens with these two?
Will be ln of 62.
120. Oh, 32.
Which is, as you said, ln of 32. Right, so there's the answer, ln of 32. Alright, now this next one, I'm going to clarify something for you because some people were confused, right? When they see more than 2 terms, they didn't know where to put, which one goes on top, which one goes on bottom. Some people were thinking like, okay, I'm adding z to the 5th, I'm adding that to y to the 4th, but y to the 4th is on the bottom because it's a minus, so I'm going to put both of them on the bottom. That's not what you do. There's a very simple way to look at these. Is when you see more than 2 terms, right? Just go ahead and write your log, so ln. Go ahead and put a fraction line because you know something's going to be on top, something's going to be on bottom. Right? And then anything that is adding is going to be on top, and anything that's subtracting is going to be on bottom. Very simple. So the starting one, x cubed, it's positive, right? So it's going to be on top. What else is going to be on top now then? Z to the 5th. Why z to the 5th? Because it's plus. It's adding. And what's going to be on the bottom then? Y to the fourth. Why is that?
Because it's subtracting.
Because it's subtracting. That's it. That's it. Simple. No, don't overthink it. It's just anything that's adding on top, anything that's subtracting on bottom. So F. How would I do F then? And then? Right, you want to go ahead and draw a fraction line because you see more than two terms. And on top is what? A squared, because that's not negative, right? And what else? B and C are on the bottom. And why is that? Both of those have a subtraction. So those go on the bottom. That's it.
Because like basically both of them are negative.
Yeah, exactly. So what's positive, what's negative? Exactly. Alright, that's it. And now, we also need to be able to go backwards, right? We need to be able to expand. So let's take a look at some of these. A, ln of xy squared. How would you do this one? What would your first step be here?
Let's separate the x and y.
Separate x and y how?
L and x minus L and y.
You said minus?
Plus minus 2.
Alright, let's go step by step, so we can really show. This is notes, right? Right, ln of x plus ln of y squared. Right, and then from here, what do we do? Whoa, we're expanding. You just told me what it was originally. Plus 2 ln y. This is the power property. We're going backwards. There we go, and that's it. ln of x plus 2 ln of y. All right, next one, B. How would we go about this one? Right? Right, why did you put a minus in front of the y squared and the z, ln? Because they're on the bottom of the fraction. That's right. And we've got one more step here, and what is that to do? Alright, we're moving the exponents in front. So 3 ln of x minus. And there's your answer. Okay, C is a little different. What do you think you would do first on C? Put the 3 in front first, right? Because the 3 is being applied to both A and B. We're going to move it to the front with the power property. 3 ln of AB. Now what do? How so? 3? Parentheses, very good, because the 3 is being applied to both of those terms, right? So if we put parentheses, it's like we're distributing the 3's to both terms. Okay, so 3 parentheses and then? That's right. There you go. And so, if C is done like that, how would we do D then? And there we go. That's it. Very good. Alright, lastly guys, this last question right here, it says simplify. This is just where you're getting rid of things, you're canceling things out when you can, okay? Some people on the quiz made this very complicated. They were like, what do? I need to show some steps or whatever. There's not really any steps to show in most of these. You just look at it, and you should be able to get the answer right away. On A, do you know what the answer would be? Negative 4x. Why is that?
Because ln and e are inverse.
ln and e are inverse. Because ln is log base e, and the base of e. Those are inverses. They cancel out, so the answer is just negative 4x.
The next one is 2x plus 3.
Exactly, because this base of e and ln with the base of e, that cancels out, and then your answer is just 2x plus 3. Very good.
That'll just be 7 the next one.
No, because say. All right, third one right there. You can't do it because the 7's in the way, right? You see the 7 blocking you right there?
Yeah.
Yeah, you can't cancel them out because it's cancel blocking there. All right, so but what can you do with the 7 though?
Cross it out.
You can't just cross it out for no reason. Come on now. Use your properties of logs. What can you do with that 7?
You can make it a base.
You You can't make it a base. Make it an exponent. Remember, when you have a number in the front of a log, what can you do? You can move it into the exponent spot, right? So we can change this to say e raised to the ln x to the 7th.
Then the answer's still 7.
That's not 7.
Excellent.
X to the 7th. Remember, because e only cancels out the ln. Boom. Leaves you with x to the 7th. And that is it. That's it, guys and girls. Okay, so that is the last set of notes. So until next time, see you then.